What we have here, guys, is we have this function and we've changed the radians into degrees. Now we're going on to the calculator. We're going to enter y equals sine x. Then we're going to start at 0 degrees. We have to go as high as 180. If we go up in steps of 30, I think we'll get everything, will we? What about steps 30? And what happens there? Yeah, 30 degrees. Okay, and what will that do for us? It will give us all the it gives us all the points all the way down, all the way to 180. Okay. Now you'll see them on your solutions. I'll just take them down quickly here. So when you take all these down, what you're going to get is your 0, 0, 0.6, 0.5, your 0.866. You're going to get your 1, your 0.866, and what else are we going to get here? 0.5 and 0. Now what does that mean? We have to use the trapezoidal rule. What does it mean by trapezoidal rule? H over 2, yeah, what? Plus last 2 times remain, or rest, whatever you want to call it, 2 times remain, right? Now, what is our gap along the bottom? We can't say 30 degrees, remember we have to use radians, so what's the gap between each one? Is it even? Let's put everything in terms of sixths, if you don't mind, right? What's a third in sixths? So I'm going to change that to 2 pi over 6. What's a half in sixths? 3 pi over 6. What's 2/3 in sixths? 4 pi over 6. I think it's safe to say that the step is h is pi over 6. Would that make sense? That the gap between each one is pi over 6. Now what are the heights? Well, the first height is 0, the last height is 0. So that's our first and our last. This one here is, that's 0.5, that's 0.87, let's call it. That's 1, that's 0.87, and that's 0.5. Okay, just a bit of closure. Now, trapezoidal rule, pi over 6. First plus last is going to be 0 plus 0. That's going to be no good to us. Plus 2 times remainder, so we're going to add the 0.5 to the 0.866 plus the 1 plus another plus another 0.866. Huh? Oh, pi over 6, then divide that by 2. Yes, you're right, David. It's h divided by 2, so it's pi over 12. Okay? 0.66 and then plus your 0.5. Now, if you're wondering how you're going to enter this in the calculator, right? We'll start off with press the fraction button here on top. That's going to be your pi over 6, isn't it? And then press a fraction, pi over 6. It should be pi over 12 if you do it properly, right? So it'll be 6 on top, pi here. Yeah, I'll show you in a second, Louis. And then underneath it's 2. Alright, that didn't work out as well as I would have liked, so I obviously got that wrong. So let me show you what happens here. See, when you multiply a 6 divided by 2, the 2 inner fractions multiply by each other to give you 12. Or conversely, you take the 2 to the top, turn it upside down, and multiply. So it's a 6 by a half, which is a 12th. Okay? So pi over 6, if you want to write it this way in your calculator, just to cure your curiosity, if you want to do pi over 6 divided by 2, you write it that way if you want. There's your pi over 12. Alright? So it's going to be pi over 12 multiplied by all that there. I don't think you need my help this time to write all that into your calculator. And your answer, did anyone get the answer for this? Since you didn't, it's going to be 1.95. 407. Okay with you guys? Now, what we're going to do for part C, use integration to find the actual area. How do we do that? So just rub all this crap out here. Don't need that anymore. Now, area under a curve. dx. What's the limits? Where do you start and end? 0 to pi. And what's the function? Sine x, right? So what we're just going to do here, we'll just get all this here. I'll bring the 0 later on. Okay, so we're just going to drag all this down to our question below, okay? So there we are. Oh dear. Oh, the joys. There you go. There's my dx. And eventually I'll get my 0 back. There we go. Now, what happens when you integrate sine x? What you get?
1.
You get minus cos x. You just look it up. You differentiate the angle, but when you differentiate this angle, it's worth 1. So therefore you don't have to put it in. Okay? It doesn't have to be there. From pi to 0, yeah? And then what we're expecting an answer of, roughly around 1.95 somewhere, yeah? So it's going to be minus cos pi minus cos 0. And oddly enough, this will turn out to be an answer of 2. Is that right, you guys? Now, the last question, I believe it tells me to work out the percentage error in my answer. Okay, so I'll stay down here for a second. Ask me to work out my percentage error. Okay? Now, percentage error. So, what we're going to do here is you do error. Anybody know the next part? Divided by? Is it true value? Not the original value, the true value. Okay? Which one's true? 2 or 1.95? 2. 1.95 is an estimate. Remember we said trapezoidal rule is an estimate? And that it should be like a curly equal sign to signify that it's an estimate and not exact. Okay, so what's our error? It's 2 take away 1.95407, yeah? Whatever that is, let's do it up here. 2 minus 1.950. 0.0493 or whatever that is, right? So 0.045903. The true value was 2 multiplied by 100, and what you get? You're going to get about 2.3%. You'll get 2.2965, which also rounds off to 2.3%. Is that okay with you guys? Any questions? If you're asked, wonder where I got the minus 2 from, or the 2 out of this. Okay, was it 2 or minus 2? It was 2 as it turned out, right? So what I did was, I go to mode setup. I can put it into radian mode. Okay, and then what I said is minus cos pi. It's a good question. Minus cos pi. Minus cos 0, yeah? 2. Okay? It's the same thing as minus cos 180. And cos 180 is minus 1 and minus cos 0. Same stuff. Alright guys, moving on. Okay, so the next question we're going to do is we'll just concentrate. So we've gone from question 9 to question 6. And in question 6, we're asked to integrate 5 cos 3x dx. Now, what can I do with the 5, lads? I'd bring the 5 outside, okay? So I'd rather do 5 cos 3x dx. What did I tell you about the angles? They always stay the same. So it's only the cos that turns into a sine. Now the 3x stays the same, but what's the hidden part, guys? The hidden part. Differentiate the angle. And so you differentiate the angle, you get 3. So you divide by 3. Now, there's going to be we also have to multiply this by what, guys? See our 5 on the outside? So what are we going to get when we multiply that in? 5 sine 3x. The angle can't be affected, remember that. Over 3. And then there's no limit, so plus c. Is that okay with you guys? Yes. All right. Now, the weird thing about differentiation is, imagine I gave you an equation like this. Imagine I said y equals x squared plus 2x minus 3. What can you tell me about that? Y equals x squared plus 2x minus 3. What can you tell me about that? What shape is it? It's a U-shaped function, correct? Okay, that other one could have been a bit more straight. It's a U-shaped function. What else can you tell me about it? So it goes up and down, doesn't it? Now what happens if I differentiate this? What happens then? I get dy dx equals what? 2x plus. What type of what type of equation is that? It's a linear, isn't it? It's basically y equals 2x plus 2. It's basically a slope of 2 and an intercept of 2 as well. And you see that you actually get a straight line from that, yeah? What happens if I differentiate that then? What happens if I differentiate a second time? d2y dx squared becomes 2. And what happens if I draw y equals 2 then? What happens then? Horizontal line across at 2. Now, the reason why I did that was they've actually given you the result for the line. Okay? What they told you is the derivative is 2x minus 2. Does that make sense? What differentiates into 2x minus 2? Can anybody tell me? You get that by integrating it, okay? And what do we're going to integrate 2x minus 2 dx. And what do you say it was, Whelan?
X squared minus 2x.
Whelan said x squared minus 2x, and he's not wrong. However, I can put any bloody number I want here, can't I? I could put 1,000. I could say plus Connor Higgins. It doesn't matter, right? It's going to differentiate and it's going to turn into, it's going to disappear, isn't it? So I have to use a letter to represent that. What letter would you like me to use? Let's use C. Okay? But it does tell me something else though, doesn't it? It tells me that the curve has a point. When x equals minus 2, what does y equal? Y equals 0. That should satisfy the equation of the curve, because that point is on that curve. So replace y with 0, replace x with minus 2. What happens here? 4 plus 4, 8, yeah? C plus 8 equals 0, so what does that make C? C is minus 8. Therefore, what's the equation of the curve? It's x squared minus and minus 8. Alright, you guys? When you differentiate that, what you get? You get 2x minus 2, don't you? It's a U-shaped curve that when you differentiate it, you get 2x minus 2. And the point minus 2, 0 is on this graph. If you weren't sure, how would you check your answer? Table function really quickly. What's a minus 2x? And what's the other one? Minus 8. Starts what does it want? Minus 2, 0, is it? Let's start at minus 3. That'll at least tell me if it's minus 2 is on it or not. Look now. 3, 7, minus 2, 0, 1 minus 5. So you've proven that that point is actually on your graph, haven't you? There's no problems there. What does it mean by average value? Will you find that in your tables? Average value in your tables, is it? It's 1 over b minus a, b to a, f of x dx. Now what do I mean by b and a? Upper and lower limits. And what's the upper and lower limit here? 3 and 0. What's the f of x function? X squared minus
2x minus 8.
Lads, if you didn't get the answer for part 1, could you continue to do that? Literally make up an answer. Or just don't include the minus 8 and run through the procedure anyway to pick up marks. Do you understand? Just because part 2 stops you doesn't mean part 1 stops you doesn't mean part 2 does either. So you can just make up your own answer for C and just drive on and try to pick up marks here. Okay, so what do you do now? Oh, sorry, there's no equal 0. The equal 0 is wrong. It's not a solved question. It's an integration. So what do we do here? It's integration test, lads, so not genius in them, but I think we might integrate. Yeah?
9 minus 6.
Yeah?
What?
Add 1 to the power.
Oh, yeah, sorry.
Add 1 to the power, divide by the new power.
Yeah.
Add 1 to the power, divide by the new power. What's 2 take away 2? Just x squared, isn't it? Okay. And then add x to the number. And say x, and that's from 3 to 0. If you put zeros in, what will happen? 0. So it's just going to be 3 cubed over 3 minus 3 squared minus 8 times 3. What happens then, lads? You're going to get an answer of minus 8. The average value is minus 8. Is that okay?
Yeah.
So that's question 9 followed by question 6, yeah? We'll move on to question 7 now. Are we happy to move on to question 7?
Yeah.
Any questions on that? No. Okay. Or is it question 6? Oh, sorry. It's what? Oh, it's question 7 on my list, but it comes from a question 6 in one of the past papers. Is that correct? Okay. Write down 3 antiderivatives. What does it mean by antiderivatives? What will integrate into that is what it's asking us. Okay, so what will integrate into that? Let's try this out. What about x4 divided by 4? What will that differentiate into?
Differentiate?
No, what will x4 divided by 4 differentiate into?
X cubed.
It will. Add 1 to the power, divide by the new power. What about 3x? What about minus 3x squared? Add 1 to the power, divide by the new power. So what happens to those what happens to those 3's? It's minus x cubed. And finally, what differentiates into 3x? Oh, sorry, into 3. That's one answer. What could the next answer be? Exactly the same thing, except, I don't know, a 10 at the end?
You can put the x4.
Same answer, but with 10 at the end. Will that differentiate into this up here?
Yeah.
Give me another one.
With a
Same thing again, but
minus 6.
minus 6 or something like that. If you differentiate any of those 3 answers, they all turn into the top answer. What is meant by an indefinite integral of a function f? Okay, I'll read it out to you, right? The indefinite integral of f is the general form of the function whose derivative is f. Okay? Basically what happens is, I'm trying to think now. Okay. Imagine you have a function f, okay? And the function is, let's say the function is what this up here, yeah? What happens when you integrate that? It's the integral of that function plus a constant. Would you agree with that? The indefinite integral of that function is the integral of that function plus a constant. So if I said f of x equals x squared plus 3, what's the indefinite integral of that? It'd be x cubed over 3 plus 3x, and then what?
Plus 4.
Plus c, where c represents a constant of integration. Does that make sense? So you explain something to that effect. You can check out the market scheme for that. Okay? Write down an indefinite integral of g, a function of part 1. An indefinite integral. So antiderivatives. It's just one of these, except you use a plus c instead of. You don't use 10 or 6. You use plus c. Okay, so that's 1/4 x power 4 minus x cubed plus 3x plus c. Now this is the one I really want to get to, right? This one's a good one, right? It gives you a hint. It doesn't have to give you a hint, okay? It can go straight to this question here. You can go straight to this here, okay? So it doesn't have to give you a hint. I'll do another version of this question in a second as well. Paste. Okay. So it can ask you what's the integral of ln x dx, and you might not be able to find it. So here's what you do. It usually will give you a start off. It usually gives you a start off, right? So what happens is it says y equals x ln x. What does this mean? Find h dash x. What does that mean? First derivative. What rule am I going to use? Chain rule. Or Chan rule. Right? Du dx equals 1 v, lads, ln x. And what's the derivative of that? Derivative of ln x? You look up in your tables, yeah? It's 1 over x. While I'm here, what's the derivative of ln 3x? 1 over 3x. Differentiate the angle? 3. So oddly enough, you still get 1 over x. It's a weird one like that. Is that alright? You need to revise that exercise if you don't remember. Now, let's do the product function. So I'm going to do this here, guys. Anybody tell me? U times the v dx, x times, anybody? U times the v dx, so that's 1 over x, isn't it?
Yeah.
And next part, phi times the u dx, 1 times ln x, okay? So it's basically 1 plus ln x. Would you agree with that? 1 plus ln x, and that equals dy dx, okay? Now, does anybody remember the trick to these types of questions? To find the next part. What we do is we take this last line and we say dy dx equals 1 plus ln x. We're looking for ln x dx. How could you turn that into ln x dx from that last line? Integrate. But before you integrate, cross multiply. Bring the dx up to the top. So you're getting rid of it from the bottom. It's in the bottom left position. It's divide on the left side, which makes it multiply on the right side. Then what? 1 dx plus ln x dx. I multiplied it out. 1 by dx, ln n by dx. Now what can we do? What have we decided to do both sides now? Decided to integrate. How do you integrate, guys? How do you integrate? What would the answer be for 1 dx? It'd just be x, wouldn't it? Can anybody use the same logic for 1 dy? Just be y. What's the integral for 1 dx? X. What's the integral for ln x dx? I think that's the whole point of the question, isn't it? Reread the question. What's the point of it? To find the integral of ln x dx. So, bring the x over to your side. Now it's y minus x equals the integral of ln x dx. What is y? I'm telling you, what is y? Go back to the top. What is y? Y is x ln x. So your answer is x ln x minus x is equal to the integral of ln x dx.